This is section 11.2, day 2 on displacement and distance traveled. Recall that when a particle moves along a line with velocity v of t, the displacement or net distance traveled from time t equals a to t equals b is given by a to b. This is displacement of the object and not necessarily the position. While the total distance traveled in that time interval is given by the integral from a to b of the absolute value of v of t. If we want to find total distance traveled, we make the function completely positive. When a particle moves in the plane with velocity vector v of t, displacement and distance traveled can be found by applying the same integrals to the vector v, although in slightly different ways. Definition: displacement and distance traveled. Suppose a particle moves along a path in the plane so that its velocity at any time t is v of t equals v1 of t v2 of t, where v1 and v2 are integrable functions of t. The displacement from t equals a to t equals b is given by the vector. Now this is displacement. Now if we wanted position, this is what this talks about. The preceding vector is added to the position at time t equals a to get the position at time t equals b. So let's say the particle starts at 3, 4. If we want the position, we would add 3 to this displacement, the x coordinate, and we would add 4 to this displacement, the y coordinate. Originally we have displacement, and then when you add this to the position, you get the new position. The distance traveled from t equals a to t equals b is the integral from a to b of velocity, the absolute value of velocity, or in vector terms, we have integral from a to b of the square root of v1 squared plus v2 squared. In exercises 37 to 40, the velocity v of t of a particle moving in the plane is given, along with the position of the particle at time t equals 0. Find a, the position of the particle at time t equals 3, and b, the distance the particle travels from 0 to 3. In part A, we are going to take 1 plus the integral from 0 to 3 of e to the t minus t dt, and then the y-coordinate will be 1 plus integral from 0 to 3 of e to the t plus t dt. So let's just do this on the calculator. We have math 9. Let's see, we have e to the x plus x. Actually, on this one it is minus x. Our variable is x, and we're going from 0 to 3, and we are also adding, let's move that back, we're also adding 1 to this. So we have 15.586, 15.586, and then we can do an entry and change this to a plus. And on this one, we're going to have 24.586. On letter B, we want to find the distance the particle travels from t equals 0 to t equals 3. So we're going to integrate from 0 to 3 of the square root of e to the t minus t squared plus e to the t plus t squared. So we go to our calculator, math number 9, and we have the square root of e to the t minus t squared plus e to the t plus t. And let's close that. And that squared. And we have comma t comma 0 to 3. 27.791. So that's equal to 27.791. A particle moves in the plane so that its position at any time t from 0 to 2 pi is given parametrically by x equals sine t and y equals cosine 2t. Find the velocity vector for the particle. B, for what values of t is the particle at rest? Let's just start with A. Find the velocity vector for the particle. So letter A, the velocity vector is cosine of t, comma, we have negative 2 sine of 2t. So there's the velocity vector. In letter B, we are asked for what values of t is the particle at rest. Well, here's the velocity vector right here. We want to know when is cosine of t equal to 0 and when is negative 2 sine of 2t equals 0. And we want to find the value that makes both of these equal to 0. Then there will be no velocity at all. Well, cosine of t is 0 at t equals pi over 2 and 3 pi over 2. That's where cosine is 0 from 0 to 2 pi. On this one, we can divide both sides by negative 2, and we get sine of 2t equals 0. We get 2t is equal to inverse sine of 0. So 2t is equal to, we have 0, we have pi, we have also we have 2 pi, and we have 3 pi, and we have 4 pi. And we can use all of these because we're not talking about t, we're talking about 2t. So t is equal to 0, pi over 2, pi, 3 pi over 2, and also 2 pi. So the two values that these have in common are pi over 2 and 3 pi over 2. So for B, t is equal to pi over 2 and 3 pi over 2. Let's look at letter C. Write an equation for the path of the particle in terms of x and y that does not involve trigonometric functions. Let's go back up to them. It's x equals sine of t. So x equals sine of t, and y is equal to cosine of 2t. So cosine of 2t. So we want to eliminate the t's. Well, I do know that cosine of 2t is cosine squared of t minus sine squared of t. That's the double angle formulas. And I want to get rid of the cosine here. We have y is equal to 1 minus sine squared t minus sine squared t. And that's equal to 1 minus 2 sine squared t. Now, x squared is equal to sine squared if we square both sides. So now y is equal to 1 minus 2x squared. Sketch the path of the particle. Let's put our calculator into parametric mode. There we have parametric. We can go to y equals. X is equal to sine of t, and y is equal to the cosine of 2t. And we can graph, but we're going to go from 0 to 2 pi. I think that's what the default is, 0 to 2 pi, so we should be good to go. So letter D. Can we, I guess it's at negative ones and lots of ones. So 1, 1, negative 1, negative 1, and it looks something like that. A particle moves in the xy plane so that its position any time t from 0 to pi is given by t squared divided by 2 minus natural log of 1 plus t, and y of t equals 3 sine t. A. Sketch the path of the particle in the xy plane below. Indicate the direction of the motion along the path. So let's change our mode to parametric and go to y equals. And I already have the functions typed in, so that'll save a little time. And let's watch the graph. And the motion, or the path, goes from 0, 0, goes up to about 3, and then goes down like that. And we will also indicate that the path is kind of going from left to right with little arrows. At what time t does x of t attain its minimum value? What is the position x of t, y of t of the particle at this time? So we want to know a minimum value of x. So x prime of t is equal to, we have t minus 1 over 1 plus t. So we want to know when this is equal to 0. That's where mins and maxes happen. So let's change our mode back to function. We'll go to y equals, and we have t, or x in this case, minus 1 divided by 1 plus t, or in this case x. So let's graph this function. And this function is 0 somewhere right there. So we're going to go calculate a 0, and I'm guessing it's between 0 and 1. And how about 0.5 as a guess? And it is, the t value will be 0.618. So t is equal to 0.618. So we know at what time this happens, and what is the position x of t, y of t of the particle at this time. So now we can go back to parametric mode, and we can go calculate a value when t is 0.618. We'll let it graph. We have 0.618, and the position is approximately negative 0.290, comma 1.738. Now, what time t is the particle on the y-axis? Then we'll find the speed and the acceleration vector of the particle at this time. We know that something is on the y-axis when x is equal to 0. The x is the t squared divided by 2, so we want to know where t squared divided by 2 minus the natural log of 1 plus t is equal to 0. So we'll have to go back to function mode, and this time we'll put in t squared divided by 2, and then minus the natural log of 1 plus t. Let's graph this, and after 0 we're at 1 point something. That's when this function is equal to 0. So we go calculate 0. It looks like it's between 1 and 2, and maybe 1.5 as a guess, and it's actually 1.286. So t is equal to 1.286. That's when the function is on the y-axis. Now it says find the speed and the acceleration of the particle at this time. So to look at the function, I can go mode back to parametric. We're going back and forth today, and y equals. So find the speed and the acceleration of the particle at this time. So we need the velocity vector, which is 2. Actually not 2, because the 2's will cancel out. The velocity will be t minus 1 over 1 plus t, and then we have 3 cosine of t. And we're going to evaluate this when t is equal to 1.286. Let's just go to the main screen, and we have 1.286 minus 1 divided by 1 plus 1.286. So the x will be 0.849. So 0.849, comma, and then I need 3 cosine of 1.286. And we get 0.843. 0.843. And then we were asked, we found the speed. Actually, this is now the velocity vector. So the speed is the same as the magnitude, which is the square root of 0.849 squared plus 0.843 squared. So we have the square root of 0.849 squared plus 0.843 squared. And we get 1.196. 1.196. And then we need the acceleration vector of the particle at this time. So we have 1, so the acceleration is equal to 1 minus, this is actually 1 plus t to the negative 1, so that's going to be plus 1 over 1 plus t squared, comma, and then we have negative 3 sine of t, and we're evaluating this at t equals 1.286. So we go back to the calculator. We have 1 plus 1 divided by 1 plus 1.286 squared. And we get 1.191. So 1.191 comma, I need -3 sine of 1.286. And that is -2.879 chevron.